Okay, let's move on to the Romeo and Juliet problem. This one's again pretty wordy, so I'll leave that to you to look at on your worksheet. But I'll also describe what happens here. So we're given this situation where there's a projectile that is launched, and I'll just kind of draw it in. Our brains love pictures, right? That's launched here, and we're not told anything about the initial speed, initial velocity, initial launch angle, nothing there. I'm going to go ahead and just call this V prime. I don't know anything about it, but I got to call it something. And then we're given a really important piece of information, though, and that is as the projectile crashes through the window, which I'm showing here with this break in the vertical line, that it's traveling horizontally. So just as it crashes through the glass, this is the wording from the problem, the pebble is moving horizontally. So we know that this here, as it goes through the window, we know that is what we can call the apex of the motion. That's really important there. So it's just traveling only horizontally right there. Okay. So that's a bunch of information. And also, what we're given in this problem is these x prime and y prime. So when the pebble crashes through the window, it has traveled some horizontal distance x prime and some vertical y prime. So let's also label those in this situation here. So this is given as x prime, and this is given as y prime. So those are just basically given to us as distances, but we are going to make those into our values for substituting into the kinematics equations. Okay. And I think that's pretty much what we got here. So let's put a coordinate system on this. Coordinate system consists of an origin and a sign convention. I'm going to go ahead and place the origin at the launch point. You don't have to do the same thing, but I find that helpful. And then for sign convention, I'm going to use upward positive y and rightward positive x here. Upward for y, since my initial velocity in the y is upward and my y displacement are both upward directed. I understand my y acceleration is downward, but 2 out of 3 are upward, so I'll go upward positive. And in my x, I've got everything directed rightward. X displacement's rightward, and x initial velocity is rightward as well. So let's have a look at that initial velocity and break that up into its components so we can at least have that in our minds, right? So here's this v prime that again, I don't know anything about. The problem doesn't give me anything about that, but I can break that up into its components and at least be kind of thinking about what those, picturing those. So here's v prime x, and then there's a vertical or y component, v prime y, and I'm going to remind myself that positive y is upwards and positive x is to the right. And so that just allows me, when I need to grab those components later on in my algebra, when I look at that picture, it connects my brain to not just the letters, but what those letters mean in space. And we want that connection in order to be able to do our work well. So I'm going to actually focus on the vertical first. You can kind of maybe think about why that might be. But the vertical, I have a bunch of information in here about the vertical. It's really nice. I know that um, basically I'm given the apex of the motion, or the maximum height is equal to this y prime. I know that because the problem tells me as the pebble was going through the window, it was traveling horizontally. For a projectile, the only place that happens where the y velocity goes to zero is at the apex of the motion. If you don't remember that, go back and look at that in the textbook. It's important to understand what's happening at the apex or the top of the motion. So what I'm going to do here is try to determine v prime y, so the y component of my initial velocity here. And the general equation that I'm going to look at here, notice that I'm not given times for anything, but I am given a position. So I'm actually going to look at the equation of position with respect, I'm sorry, velocity with respect to position. So I'll write that equation out. This is a useful one. This is just one of our kinematics equations, but it's the velocity with respect to position equation. And sometimes it's just what you need. So for this problem, I'm going to be applying this at the apex of motion because I know that at the apex, I know that my Vy is equal to 0 at the apex of motion. My V initial Y, that's what I'm trying to find, actually. So that is V prime Y squared plus 2. Acceleration in the Y is going to be negative G, and my Y displacement there is positive Y prime. I know that Y is equal to positive Y prime, positive because it's above the 0 and I have upward positive. It's equal to that value at the apex. So this allows me to actually solve for Vy, Vy prime, root 2 Gy prime. I got it. Done. So, well, not done with the whole problem, but done with the y component. So I have the y component of the initial velocity. Woohoo. So now I just need to determine the x component of the initial velocity. Um, so this is slightly more involved to do this, but let's go ahead and figure out, and well, let me pause for a moment and ask you, like, why can't we just follow the same process to determine v prime x? So look at that for a moment and think about why. Well, the x acceleration is 0. So that particular process that I went through with y isn't going to render me any useful information for x. Okay, you can try it, go through it, but it's not going to give you much. So for x, I am going to look at position with respect to time. So I'll write out my general equation here. So here's my general equation for position with respect to time. And then I need to process that so that it is applied to my whatever the situation I have here. So my x final in this case is x prime. My x initial is 0. I've set the origin at x naught. I can express my initial velocity in the x. That's v prime x. That's what I'm trying to find, actually. And my acceleration in the x is 0. So that's 0. So if I'm looking for what this tells me here is that Vx prime is equal to x prime over the time of flight. So I actually do need the time of flight for this one to just to get the x component. So in order to get time of flight, I often will go to my vertical motion in order to get time of flight. And now I know a whole bunch about the vertical motion, so that's kind of nice. So I'll switch gears here and I'm going to say find time of flight. In order to do that, I'm going to use the vertical. So the particular equation that I'm going to use in the vertical actually is Vy equals V naught y plus AYT. So this is just velocity with respect to time. So notice that on our page now, we have 3 general equations. I'm going to highlight those 3 general equations. So we've used velocity with respect to position. That's a general kinematics equation. We've used position with respect to time. And now we're using velocity with respect to time. So this is kind of a neat problem because um, you can see 3 different kinematics equations in use. So if I'm going to take that equation and then I'll apply that right at the apex of motion, just to be clear. We did that over here where we were finding v prime y2. So I would say here, analyze at the apex of motion. because we're given so much information about the apex. We know exactly where it is. So if I do that, solve for time, time is going to be equal to Vy minus V naught y over A sub y. For our particular problem, that's equal to, at the apex, the y velocity is 0. My y initial velocity is Vy prime, and we already know what that is. The acceleration in the y is negative g, so this tells me that the time is equal to Vy prime over g. Cool. So that allows me to solve for my Vx prime. So Vx prime is equal to x prime over t, right? So that'll be equal to x prime g over square root 2g y prime. And I'm getting that because Vy prime is equal to square root 2g y prime. Cool. So now I actually have the x and y components of my initial velocity. So my final answer, then I can write that in component form. So if I'll write that in component form, I'll switch pages here to do that. My initial velocity, my launch velocity, which I'm calling V prime in this particular problem, is equal to, and you can write this in, I don't know, different notation. You can use brackets, you can use IJK. I use brackets in the written solution, so I'll use IJK here. So I could write that as x prime g over root 2gy I hat plus root 2gy j hat. And that is my launch velocity.